Hey folks, nice to have you here. Well, I thought it's a good moment to try to make a very quick sprint about 3D and processing, because this could be the perfect foundation for my upcoming course, which is probably called, I'm not really sure about the title, but I'm going to call it The Third Dimension. Surprise. It will be covering all the things you have to know about 3D, and yeah. Let's go to my website, which is timrodenbrücker.de. Maybe you are on my website now, I'm not really sure. And go down to projects. Well, these are not the projects I'm looking for, but I want to, here's the link, and just go down to redrawing images. And this is a project, or, it's not really a project, it's a set of portraits I did with processing and 3D. So processing, some of you don't know that, but processing is a comprehensive 3D software. You can create 3D animations and 3D interactive 3D spaces with it. And that's something I want to touch in this tutorial. So we are going to recreate this visual, but as you have already seen here, there's so many possibilities what we can do with this system. And this again showcases the great potential of generative design. So once we have built the system, right, we can think about what else we can do than just rotating it around its own axis. So that's going to be pretty much fun. And I will really start from zero. I will start from really a blank sketch window, and I will try to explain every single step. Yeah. It will be quite hard, I think, because, it's very difficult for me to speak English for such a long time, and also to think about the code and explain everything at the same time. And that's not really super simple, but I know I can make it. And cool. Let's go into processing and creating a sketch. There we go. First of all, this is a blank sketch window, right? So now let's create this setup function, and then let's create the draw function. Okay, so I always or mostly use 900 times 900 pixels because this is the best size for Instagram videos. And as you know, I always post things on Instagram. Some of you don't know, and I've just been chatting with some people who made my Creative Coding Essentials course. Some of you don't know that processing is a software which you can use to render any data format. So you can render images, and you can render videos, animations, MP4 files, also 3D objects. Of course, that's not so easy as in other software, but there are libraries for the most formats. So I just wanted to mention here that this is not something you create only in processing and you cannot share with the world. You definitely can. And I would like to encourage you to do so, because this is, yeah, maybe somebody else would have fun doing that course. All right, cool. Now, let me set the background color to my favorite, white or light gray. This is the light gray I always use when I don't know which color I should pick. Or, this just separates quite good from white, and it's still very, very light. So I really like this color to make things separate from the background. Well, now it's time to think, because what are we going to do in this tutorial? We want to have an image, and we want to rasterize this image, and then we want to rotate the three-dimensional, the rasterized image in the three-dimensional space around its own center on the y-axis, right? We want to have it rotating around the y-axis. And then we want to distribute the position of the tiles of the grid on the Z position. Don't get confused. I'm just thinking loud. I probably you don't understand what I'm talking about now, but I just try to explain to myself what we are going to do in this video, right? Okay, so now let's create a variable that's called img, an p-image variable, which is an image. Processing as a variable type called pImage, and it is an image. So now we can use img equals to load image, but of course I don't have an image saved inside of my data folder yet. So you probably know that, or maybe you know that images have to be saved inside of the sketch folder's data folder to be accessible for processing. So let me go to the, I just prepared this video, of course, and here is the image. I want to take this image, let me close that again, whoops, and put that image here, right, into my sketch data folder. And I can do so, and it's a very nice trick, by just dragging it above the editor and drop it. So you won't see anything in the log. It's not telling you that it saved the image into the data folder of the sketch, but it did. Now I have the image, which is called venus.jpg. By the way, Venus is a figure out of the antique Greece, I think. I'm a big fan of antique philosophy and antique history. So if you have any good links for me to check out the history of the antique, I really love your recommendations. Just in case you have the same passion as I have. Now, we have the Venus JPEG inside of the sketch. And the thing is that, this image probably has a different size. Mostly that's the case, right? So we can use the resize function to resize the image to 900 times 900. And because this image is a square, we don't have to care about the aspect ratio. One tip, if you have ever worked with images, you probably have experienced the problem that if you have resized the image, then the aspect ratio is just destroyed. And you can use 0 to keep the aspect ratio. That's a little trick here. Anyway, now let's convert the sketch into a three-dimensional sketch by using P3D. And now I can, now let's create the rasterization algorithm. Yes, let's do it. So now I need two variables. The first one is the number of tiles on each axis, because this is a square and we want to work with square tiles. We want to create a grid of square tiles. We can use one variable for both axes. So float tiles equals to 100 and let's say 80. And then we have to know how large every tile should be. So the size of the tile on both axes. And I call this variable tile W, or tile, let's say tile size, equals to, now look at this, width divided by tiles, right? Because we want to know how many tiles on the x-axis and on the y-axis should be, sorry. We want to know which size each tile should have. We can find that out by dividing the width through the amount of tiles, right? Now, let me create the algorithm to rasterize the image. For int, we create a nested for loop now, right? X, which represents the tiles on the x-axis, equals to 0, and x is smaller than tiles and x plus plus. Whoops. Parentheses, curly brackets, and now for int y equals to 0, y is smaller than tiles. Whew, this is already, writing code, talking English, explaining stuff at the same time. That's difficult and challenging for me, but anyway, I will keep on here. I won't keep you unsatisfied with this video, all right? Cool. Now, this is important. Look, we've got the sketch window, and we want to get the How to explain that? Yes, look at this. Ellipse. Now, let me just create a grid of ellipses. A very simple grid of ellipses, all right? Just to explain you how to pick the pixels out of the image. So ellipse, and it should be positioned by x times tile size and y times tile size, right? And the size of the ellipse should be, let's say 10 or something, I don't know. However, and let's just create the fill, or just fill the, oops, let's fill the ellipse black and say no stroke to deactivate the stroke here. Let's see what happens now. All right, cool, that's good, but let's just use only 10 tiles so we can see what happens. Yeah. Look, this is what I'm going to try, or what I'm going to do now. We have an image, right? And we have a grid that is meant to pick specific colors out of the image to calculate the size of each tile. All right. Now we need to know which color the pixel has that is at the same, or that is at the position of, you know, of the tile, right? We want to know what let me just create a nice mouse cursor here. Look, ellipse. But, you know, this is very helpful now, because now I can show you what I mean. Let's say 40 times 40, and I will fill this red. Now, look at this. I've got a grid, and I want to know which position a specific tile, or which color a specific pixel of the image has. So which color has this pixel here, right? And then this, and then this, and this on the x-axis. And then we go over to the next row and see what color this pixel has, this pixel has, this pixel has. So we have to go through the grid and ask for the color of the pixel to calculate the brightness, and then to calculate the size of the tile. It's very abstract. Keep calm. It's going to be clear in a minute. All right. So let's delete that silly ellipse here and the mouse cursor. So we have to find out what color the pixel has. So there's a nice function. It's called get, and you can use img.get to get the color of the pixel. So x, y would give us the color of a specific pixel. Let's create a variable here that stores that color. The problem is that this would work, but it would just give us the values of the pixels at the very top left of the sketch window, because we are not multiplicating it with the size of the tiles to distribute the tiles on the grid. So what we have to do, we have to multiply the x with tile size and y times tile size. And the problem is here now that this won't work, because x times tile size is a float. But if you want to say, take this pixel, exactly this pixel, you have to ask for an integer instead of a float, right? So what we can do here is we can convert the float into an integer, right? Super easy, hopefully. I hope you can follow me. But, you know, this is a special moment because we still haven't anything on the screen. I know this is very abstract at the moment, but once you will see that the sketch window will display something, you will see that this is going to be much more easy to understand. So try to keep going. Let's try to solve that problem here. Now I want to find out what brightness, how bright the color C is, because I don't want to work with RGB values. I want to work with a float. So we could say something like float b equals to brightness, which is a function that recalculates a color into a float, right? So this will now return a number between 0 and 255 to tell me what gray value the brightness of that pixel is. So what I always do, I use the lovely map function to map the range of 0 and 255 to 0 and 1, because it's much easier to work with. And now we are pretty far. We can now create a new coordinate system by using push and pop. Translate the pixels across the sketch window, x times tile size and y times tile size. And why not? Let's create ellipses. Ellipses, does it make sense? Yeah, why not? Ellipses that have the position 0, 0, because we are already translating with the translate function. And let's say have a size of tile size, right? So now we are recreating this grid. But look, now we have a nice grid of ellipses, right? But what I can do now is I can just multiply the tile size with b. And b is in value between 0 and 1. And if I do so, I will get this result. Look, ta-da! There's our sculpture, there's our statue. It's not really easy to recognize it because of two things. First of all, it's inverted. We have to invert the color here by just swapping 0 and 1, and we have to adjust the number of tiles to, let's say, 100 or something. Anyway, it doesn't really matter. And there we go. Our rasterized image is finished. Wow. Great, right? So look at this. This is quite cool. We can use mouse X to control the amount of tiles, which is fun. Look, now we can just adjust the rasterization effect by using the mouse position. Pretty cool, right? But that's not what this tutorial is about. It's more, now we have to bring it into a 3D space. And the sketch is already 3D. And what we have to do now is we have to rotate it around its own center. Let's do it. First of all, let me create a new coordinate system. And let me translate that thing into the middle of the sketch window. No. Well, maybe it's easier to understand if I just rotate it now. Radians, frame, frame count is nice, I think. Now, look at this. Okay, this is wrong because we are not rotating at the y-axis. That's what I wanted to show you. So now it's rotating at the y-axis. But you know, the thing is that the origin of the coordinate system is at the top left of the sketch window. So what we have to do is we have to translate it into the middle. Yeah, right? So width divided by 2 and height divided by 2. Now the coordinate system is translated into the middle of the sketch window, but the problem is the image is not really, or the rasterized image is not at the right position. So we have to, and this is something I really took it took a long time to find out how that works. I have to subtract width divided by 2 and height divided by 2 from the x and the y position. This was really so much work for me to find that out. I don't know why it took so long, but sometimes you're really stuck with very simple problems, right? And I translate it now into the middle, and as you can see, ta-da, we are very close to the end of the video because we have our visual rotating around its own axis rotating around its own axis in a three-dimensional space, and that's pretty far. So what I wanted to have is that the tiles of the that display the visual should be distributed on the z-axis to get that thing three-dimensional, right? So look at this. Float z equals to map b, 0, 1. I'm mapping the brightness value from 0 and 1 to minus 100 and 100. And I can now use, and this is magical, z to position the ellipses on the z-axis. Yep. Look. Right? Can you see that? That's pretty much, or it's very, very close to what I've been showing you in the beginning. I would like to have, as you can see, we are now working with ellipses, and the thing is that they are two-dimensional shapes. So two-dimensional shapes have no depth. Depth, is it the right way to spell that word? I don't know, but they don't have any depth, and we have to use something else than ellipse. Let's use box instead, and box just takes one value, just wants to know how large it should be. Now we have boxes instead of ellipses, right? Well, boxes always look a little bit like Minecraft or something. Let's do something cool here. We can use sphere detail to simplify spheres. And spheres are, spheres. Spheres are spheres. Now look at this. This is going to look a little bit more natural because the spheres now have a very rough detail. They look like rocks now, and this is a bit more a bit better to, well, it looks more natural, right? So the thing is that now this is calculating a sphere that has a brightness or that has a size that is quite large, and we just can just change the size of that spheres to make them a little bit more appropriate. Well, that's pretty much what I wanted to show you, right? That's exactly what this tutorial wants to cover. I think this is a great point where you can just adapt the code and try to create something by yourself. And well, please let me know what you think about this tutorial. I would love to see your results on Instagram or Twitter, or anyway, just tag me. I really love to see what you do with my tutorials. And I have a Patreon page. The more money I earn with my tutorials, the more time I can spend with it. Enjoy! Have a nice day. Bye-bye.